Hello. Today, me, Carter, and Yoonha will be discussing the ideal gas law in terms of what it means and how to use the equation in some different scenarios. To begin with, the ideal gas law was created by combining all the simple gas laws, which consist of Boyle's, Charles, and Avogadro's law. For example, with Boyle's law, pressure and volume have an inverse relationship. Therefore, in the ideal gas law equation, pressure and volume are on the same side of the equation. Compared to the other simple gas laws, Charles' law shows that volume and temperature have a direct relationship, and Avogadro's law shows that volume and moles have a direct relationship. From this information, the equation for the ideal gas law developed to be PV equals nRT. Unlike the other gas laws, the ideal gas law is based on the behavior of a gas at a single point in time, whereas the simple gas laws, meaning Boyle's, Charles, and Avogadro's, are for a sample of gas at two different points in time.
In the equation, P stands for pressure, with the units being in terms of atmospheres or ATM. V stands for volume, with the units of liters. N is the number of moles of gas. R is the gas constant, which is 0.08206 when the pressure is in terms of atmospheres, or 62.4 if pressure is in terms of torr or millimeters of mercury. And T stands for temperature in terms of Kelvin. In ideal gas law problems, you will often be given 3 out of the 4 pieces of needed information. For example, you will be given the values of pressure, volume, and moles. Therefore, you should be able to find the temperature with the ideal gas law. The first example that will be introduced is going to be a problem where you must solve for a variable on the right side of the ideal gas law equation. A hot air balloon at STP has a volume of 35 liters. What is the number of moles of gas in the hot air balloon? To start, let's identify important information that is given in the problem. At STP, the temperature is 273 Kelvin, which is equivalent to 0 degrees Celsius, but we use Kelvin for ideal gas law problems. The pressure at STP will always be 1 atm. The third piece of information that is given in the problem is the volume of the gas, which is 35 liters. The next step we must take is rearranging the ideal gas law equation so that we can solve for the number of moles of gas. And to isolate N from PV equals nRT, we simply divide both sides by RT to isolate N, and the new equation to solve for moles becomes N equals PV divided by RT. Now we just plug in the known values, which is N equals 1 atm times 35 liters divided by the gas constant 0.08206, since the pressure is in terms of ATM, times the 273 Kelvin, which ends up becoming 1.56 moles of gas.
In the second example of the ideal gas law, you will be asked to find the volume. The question reads as follows. A scientist is comparing the ideal gas law to experimental values. Using xenon hexafluoride, which is XeF6, the scientist needs to know the estimated volume with the conditions of 2.51 grams of xenon hexafluoride, 0.37 torr, and 38 degrees Celsius. First, in the ideal gas law, you need to know the moles of gas. Therefore, you must complete a mole conversion from grams to moles. If you do not understand mole conversions, please refer to the video about mole conversions. Because the molar mass of xenon hexafluoride is 245.28 grams, the moles of xenon hexafluoride in the problem is 0.0102 moles. Also, for temperature, it has to be in terms of Kelvin, not Celsius. So you would add 273 to the degrees Celsius to get Kelvin. In this problem, that would be 311 Kelvin. Additionally, because pressure is in terms of torr, the gas constant, aka the R value, is 62.4. Now that you know all the needed variables, you need to rearrange the equation to find volume. Therefore, PV equals nRT would rearrange into V equals nRT divided by P. Therefore, volume would equal 0.0102 moles times 62.4 times 311 Kelvin, all divided by 0.37 torr, which would then give you the answer 530 liters. and this is how you would approach and solve that specific problem.
This information, we hope the ideal gas law makes more sense and you are able to apply certain conditions to the ideal gas law equation to find the solution. Thanks!